Hi students, welcome to my YouTube channel. NEET. In today's section, I am going to discuss VBT or Valence bond theory from the chapter Coordination Compounds. This is a very important chapter for the examination. Mostly the questions from VBT are that is we are given a coordination complex like this COMH36 or any else. We are given a coordination complex. We have to find the geometry or hybridization, magnetic moment, magnetic behavior. Like that type of questions are mostly coming from VBT or valence bond theory. So I am giving you a small trick or some steps to easily do the questions from VBT. So the step number 1 is to check the coordination number of the complex. I think you know how to find the coordination number. I have already uploaded a video on how to find the coordination number and oxidation number of the coordination complex. I will put the link on the description box. Please take a look on it. So the first step is to check the coordination number of the complex. If the coordination number is 4, then it has two possibilities for geometry. That is, first is tetrahedral and the second one is square planar. If the geometry is tetrahedral, the hybridization will be sp3, and if the geometry is square planar, the hybridization will be dsp2. If the coordination number is 6, it have only one possibility for geometry, that is octahedral, with the hybridization sp3d2 or maybe it is d2sp3. Now the second step is to find the oxidation state of the central metal atom. To find the oxidation state of central metal atom, the step 3 is to write the electronic configuration of the central metal atom. Now the this is step number 4. The step number 4 is to check whether the ligand attached is weak or strong. It is to check whether the ligand, it is a very key step amongst this, because it is very necessary to check the ligand is weak or strong. The examples for strong ligands are CO, Cn minus, NO2, En, ethylene diamine, NH3. Weak ligands are F minus, S2 minus, Cl minus, SCN minus, Br minus, I minus. Students, look, if it is a strong ligand, these strong ligands can pair up the electrons, and if it is a weak ligand, the weak ligands cannot pair up the electrons. So students, the first question is NiCl4 2 minus. This is the first question. So what was our first step? First step is to find the coordination number. To check the coordination number, look, it is a monodentate ligand, so the coordination number is 4. So if it is 4, it has possibilities for two geometry, that is tetrahedral and square planar with the different hybridization sp3 and dsp2. So the next step is to find the oxidation state of the central metal atom. Here the central metal atom is nickel, so we have to check the oxidation state of nickel. So let's take nickel as x minus 1 into 4. Minus 1 into 4 is equal to minus 2. So x minus 4 is equal to minus 2, that is x is equal to plus 2. X is equal to plus 2 here. So nickel have the oxidation state, students, plus 2. Now we have to write the electronic configuration of the central metal atom. The electronic configuration, nickel is atomic number of nickel is 28, that is argon 3d8 4s 2, 3d8 4s2 is the electronic configuration. So draw the orbitals, that is 3d 4s 3d. We can draw 3d 1 2 3 4 5 4s. Look students, it has also 4p and 4d, but these two subshells does not have electrons, that is 4p0 4d0. So there is a 4p 1 2 3 and 4D also. 1, 2, 3, 4, 5. So this is, take another pen. So this is 3D, this is 4s, this is 4p, and this is 4d. 4p and 4d have no electrons, 3d have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Look students, here the electronic configuration of nickel is radiate 4s to 4p0, 4d0. Look, it is in +2 oxidation state. So 2 electrons will be lost. 2 electrons will be lost from the S subshell, that is S have no electrons. So 0 electrons for 4s, 4p and 4d. Now check chlorine. Chlorine is a weak ligand. Chlorine is a weak ligand. So it cannot pair up the electrons. Cannot pair up the electrons. That is, it cannot pair up the electrons. So what will be the hybridization formed by this complex? Look, here is 4 chlorine atoms. So 4 chlorine needs 4 orbitals, that is 1, 2, 3, 4. It will form sp3, sp3 hybridization. sp3 hybridization. So the first point is, what is the hybridization? sp3. If the hybridization is sp3, then the geometry will be tetrahedral geometry. Now the next is its magnetic behavior. Look, there is a presence of unpaired electrons in the electronic configuration. So the magnetic behavior is it is paramagnetic. Then the magnetic moment is mu. Mu is equal to, the equation is root of n into n plus 2. So now how many unpaired electrons? 2. So root of 2, n is the number of unpaired electrons, so root of 2 into 2 plus 2. 2 into 2 plus 2, root 8. So the magnetic moment is root 8. Look here students, that means that here it doesn't take the inner d orbital, it has taken the outer. It is an outer d orbital complex. It doesn't take an orbital from the inner d orbital. So it is an outer d orbital complex. It is an outer d orbital complex. Why it is an outer d orbital complex? Look here students, it doesn't take an orbital from the inner d, so it is an outer d orbital complex. Since it is an outer d orbital or outer orbital complex, or we can call it as high spin complex. High spin complex. Are you clear students? Now the next question is MnCN6 4 minus. The first step is to check the coordination number. Coordination number is 6. 6 is the coordination number because Cn is a monodentate ligand. Now the next step is to find the oxidation number. X minus 6 is equal to minus 4. X is equal to plus 2. So X is equal to plus 2 is the oxidation state of manganese here. Now the next step is, step number 3 is to write the electronic configuration. Electronic configuration of manganese is argon 3d5 4s2. Manganese is 25, atomic number 25. 3d5 4s2. Look students, here the manganese is in +2 oxidation state. So 2 electrons will be removed from 4s. 4s2. Here 4p and 4d is also present. Don't forget about it. 4p and 4s is also present with no electrons. So 2 electrons will be removed from 4s since manganese is in +2 oxidation state. Now we can draw the orbitals. 3d. This is 3D. 1, 2, 3, 4, 5. 3D. Then 4S, 4P. 1, 2, 3. This is a 4P and 4D. 1, 2, 3, 4, 5. This is 4D. 4S, 4P and 4D have no electrons. 3D have how many electrons? 5 unpaired electrons. 5 unpaired, 5 electrons. Okay, after writing the electronic configuration, students, the next step is to check the ligand. CN is a strong ligand. CN is a strong ligand. So it can pair up the electrons. Then how it will pair up the electrons? Look, this electron will come here and this electron will come to this orbital. Okay, then it will become like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, like this. The 3D will become like this. And 4s, 4p remains same. No change for these orbitals. 4s, 4p, 4d remains same. 4s, 4p and 4d remains same. So Cn minus pair up the electrons. Then which hybridization will be taken? Look, here is 6 Cn. So 6 Cn needs 6 orbitals. So 1, 2, 3, 4, 5, 6. It will take the orbitals, inner d orbitals. That is 1, 2, 3, 4, 5, 6. And it will form the hybridization D2sp3. So let's write. So the geometry is octahedral. Only possible geometry for the coordination number 6 is octahedral, but it can have two hybridization D2sp3 or sp3d2. But here Cn is a strong ligand, so it pair up the electrons and form the hybridization D2sp3. Students, are you clear? D2sp3. So the next is to check the magnetic behavior. Here one unpaired electron is present, so it is paramagnetic, and it has taken orbitals from inner d. So it is a inner d orbital complex. Inner d orbital or inner orbital complex. Inner orbital complex or low spin complex. Inner orbital complex are also called low spin complex. Outer orbital complex are also called high spin complex. Now we can check the magnetic moment. Let's write it here. Mu is equal to root of n into n plus 2. Number of unpaired electrons is 1. So 1 into 1 plus 2. Root of 1 into 1 plus 2. Root of 3. Root 3. So are you clear, students? This is the way you can easily do the questions from a VBT. So hope you all like my video. If you like my video, please like, share and subscribe. This is Easy NEET. Thank you.